order for the display to be 150 square inches. So we have a rectangular picture frame of uniform width with these dimensions, 15 and 20 on the outer. So this would be 20 on the outside of the frame, 15 on the outside of the frame. Now what's the question asking? How wide will the frame be? Therefore, that is our variable x. So the width here is x amount. Okay? So therefore, what can we say about the inside? Well, this distance here would be 20 minus x minus another x. Therefore, this distance here is 20 minus 2x on the inside. Okay? On the inside here, of course, this would be 15 minus 2x. So therefore, we have the equation base times height equals 150, because we know the area of the inside is 150. This is the display area. So therefore, what we're going to do now, we want to find out where this multiplication equals 150, so we're going to throw this in the graphing calculator. 20 minus 2x times 15 minus 2x. Now, what's the domain? Well, we're going to say the minimum is 0 for x, and the maximum is only 7.5, because we know that x, if it's greater than 10, this becomes negative, and when x is greater than 7.5, this becomes negative. So we cannot have negatives, so therefore x has to be less than or equal to 7.5. Y2 equals 150. We know that the y min should be 0 and the y max should be at least 200, because we want to go above 150. So we're going to throw this in the GC here, and we're going to have our window again from 0 to 7.5, and I went from 0 to 300. So when we graph, we want to find the point of intersection. So we are going to do calculate, intersect, and we're just going to find the intersection point. So, you know, we just do that, and therefore x equals 2.5. Alright, now there is another way to do this, which is algebraically. Without the graphing calculator, you would have to subtract 150 on both sides, gather like terms. After you do FOIL, you'd have to get 0, you'd have to solve a quadratic, you would get x equals 2.5 or 15, which 15 does not work because it's outside of the domain. Alright, so any